Hello everyone, I'm Rafael Alvarez and this is Alvarez Metalworks. Before we get started today, I wanted to give a special shout out to my channel sponsor, RorikSupply.com. They've been a tremendous amount of help to me when it comes to producing these videos for all of you. Check out RorikSupply.com. They have flap discs, cutoff wheels, grinding wheels, welding blankets, drill bits, burr bits, welding helmets, roll-lock discs, you name it. The list goes on and on. Use coupon code METAL, save yourself 10% off anything that you order from them as many times as you choose to use that coupon code. That's my thank you to you for supporting my channel. With that being said, let's get to work. So I'm back with an update on Project Pathfinder, and yes, it's been a year. Or more. Last video was a teardown video, which really didn't show you all of the teardown, but it was a video. This video is going to be a point A to point B, start to finish, time-lapse, voiceover type thing. Ta-da, it's done, of the assembly of the front axle. Now, the video footage that I shot was just random video footage of me actually doing the work because I was trying to get the work done, the truck done for a couple of events, missed my deadline, but that prevented me from showing you step-by-step how-to. So I'm going to just show you in this video a rough overview of here's where I started, here's where I ended, and here's some of the work that was done in between. So later in the future, I may do some breakdown videos that go into more detail about suspension geometry, the installation of the Aussie locker, made by Torque Masters Industry here in New York, as well as some other detailed types things, but not in this video. So with that being said, let's get this video going and try to speed it up. So the route I chose to go with this front axle swap was with a Dana 44 out of an early Bronco, a 1974 Bronco to be exact. Now, obviously what you're looking at here is a front axle, Dana 44, drum brakes, which is a problem. The other problem is that it's 5-lug. Ford 5-lug pattern versus Nissan 6-lug pattern, which is the same as Toyota and Chevys. They use obviously different studs for the Nissan, they're metric versus the standard studs that you would have, but the bolt pattern is the same. So what we're going to do to remedy this is we're going to be using this. This axle here is a Corporate 10 bolt. I believe it's out of a 1987 or 88 Chevy pickup. Silverado of some sort, doesn't really matter, because we're not using too many parts off of this. Initially I had planned to use the high steer knuckle off the driver's side, and I sought out this axle specifically for that knuckle. Ultimately we're not using, and I'll explain to you that shortly. So what we are using is a brake backing plate, the spindle, the hub assembly, to a certain degree, but yes, the hub assembly and the calipers, and that's basically it. So you'll see here in the work that I'm doing, I spend a tremendous amount of effort trying to get the high steer arm off the driver's side knuckle and doing a bunch of work that was really just unnecessary, because I ended up swapping out the factory high steer knuckle for a Reed Racing knuckle. Now if you look here, this is a factory high steer knuckle on the right and a Reed Racing knuckle on the left. You can see here at the upper ball joint there's a tremendous amount of bulk difference between the two. Also the webbing that goes around it. Lower ball joint, a lot of difference in the bulk size there. And on the steering arm itself, the lower factory steering arm, you see that there's quite a bit of an indent in the factory one, whereas in the Reed Racing one, it's that indent's a lot shorter, and it's just there's more material there to make it a stronger knuckle. Now, the problem with the Dana 44 knuckles is when you break these things, they tend to break right up at the upper ball joint. That little wrap around the area ball joint part, that tends to rip and break. So after looking at how much of a difference the passenger side knuckle had, because I had to buy a high steer Reed Racing knuckle for the passenger side, after seeing the difference between the two, I just could not justify putting that factory high steer knuckle on there. I knew that I had to just go out and buck up and spend the, $250 or whatever it was in shipping to get the, another Reed Racing knuckle. So that's what I did. And that's why I didn't use nearly as many parts off of the corporate 10 bolt as I initially thought I was going to. So the first thing that we need to do on the Dana 44 housing is remove all of the outer components, which is the knuckles, brakes, spindles, hubs, so on and so forth, which in this video sequence, they're gone. The inner axle shafts are still in there. The outer axle shafts are not. I gave them to a friend. But what I'm working on here is I'm using my Everlast Power Plasma 50 and cutting off all the brackets for the shocks as well as the track bar mount. And then I'm going to be using some cut-off wheels and some hammers and wedges and whatever I can come up with to get the radius arm wedges off the axle tubes. Those are the big wedges you see on each end of the axle tube there. They're not easy to remove, okay? And my one piece of advice I can give you with this is try to cut the wedge, not the weld. Be super careful not to cut too deep because you don't want to cut into the axle housing. If you do, you really need to weld a bead across that cut to replace the metal. You see here I just knocked off that wedge, and if you look closely here, you'll see, there's a tremendous amount of material still left on there. The weld plus some of the wedge material, some of the brackets here, I've got a lot of grinding left to do. Oh, and yes, this axle is a bit rusty. We're in upstate New York, and that comes with the territory. But it's not in bad shape at all. And by the end of this video, you'll see this thing looks like $1,000,000 when it's done. It cleans up real well. So now what I'm working on here is removing the inner C's off the axle housing, off the axle tube. Again, this is a slow process, takes a lot of patience, and my one piece of advice I can give you here is use a 4.5-inch angle grinder with cut-off wheels, not grinding discs, cut-off wheels. You see I'm using a flap disc here. That's just to remove, some of that bracketry from the wedges, the radius arm wedges that were there. But when it comes to removing the inner C's, use the cut-off wheels. And you're cutting not just the surface part of your weld on what you would think. Don't be scared to cut into the axle tube or cut into your inner C because you will have to. When they assembled this from the factory, everything was flat, and you think, oh, just cut the flat, anything above the flat surface off, and it should come right off. Well, that's not the case because a good weld will penetrate the base metal. So we need to dig into the base metal, which is the axle tube as well as the inner C, to get all of the weld out of there so that when we start banging it with a hammer like you see here, that it will eventually develop a crack where the weld was, and then you're home free. Once you see that crack, you've ground out enough of the weld where you can start smacking it and it'll come off. Don't be scared to hit this. You don't want to hit the very ends. You want to hit it as close as possible to the axle tube so you don't bend the inner C, but you're going to have to hit it hard. This is not for the meek here. So you can see it's coming off here. I'm feeling like I just won the lottery because this was a tough job for sure. So it's off here. If you look at these still images, you can see here on the end of the axle tube, you can see a little bit of where I ground it out. This picture right here, the whole axle housing's there. You can see on both ends where I ground it out. The next step is to start tearing down the corporate 10 bolt. And like I said earlier, I tore into this a little bit more than necessary. Ultimately, what we need here is just the hub assembly. Don't even need the rotors because the rotors are pretty beat up on, and might as well just change them out, get new brakes in there. So I'm going to need the hub assembly, the spindles, as well as the backing plates, calipers, and that's it. So anyway, what I'm doing here is removing the auto locking hubs, the factory auto locking hubs. I'm not going to be reusing them. I'm going to put some mile marker aftermarket hubs on there that are manual. My theory behind it is I know that the manual hubs are stronger than the auto locking hubs. They tend to have less issues. But the manual hub I'm trying to make as a fuse, basically a weak point in the entire setup. I do have some slugs so that I can make this, so I never have to lock the hubs. The hubs are always locked. But I don't think I'm ever going to run those, to be perfectly honest with you. It hurts fuel economy and whatnot, and it just ultimately puts a lot of wear and tear on the front end that's unnecessary, and stress on parts of, just with the just regular driving. So um, I'm pretty confident the front axle, when it's completely built, is going to be plenty strong enough for what I need. But just in case, I'd rather have a hub blow out on me than for me to blow an axle shaft or worse, a ring and pinion. So what you see here is like, sure, I'm gonna get some flack from this. You guys are gonna be like, that's super dangerous. Whatever. um, all of this is very, very rusty, and yes, I'm going to salvage those backing plates. I could have just went out and bought some new ones, but I cheaped out and said, you know what? For what? I've got a sandblasting cabinet. I can restore these things. They'll be fine, and they're fine. So, anyway, the nuts on there are very rusty, so I'm applying heat with the MAP gas torch and zipping them off. I tried to use my Milwaukee Impact, but just didn't have enough guts behind it. So I'm using my Ingersoll Rand Impact to get it off. And here comes the hard part. There's a special tool to remove a spindle, which I do not have. It screws on to right there at the end of the spindle. You got the threads. You could also use that tool to grease your spindles as well. So it's a good tool to have if you have the availability to get it. I did have the availability to get it, but I just said, you know what, the hell with it. I'm doing this the hard way. Heating it up. It's rusty. It should have come out a lot easier than it did. Sat there and with a punch and with that chisel and tried to pop it out of there. Eventually it came out. Now what I'm doing here is removing the axle shaft, and you see I'm struggling with this a little bit. This should just pull right out. The axle shaft is damaged. The U-joints there and the axle shaft are in bad shape, and plus the rust and the scaling and everything on there prevented it from coming out of the knuckle as easily as it should have. Those are super tight clearances when you pull them out. If you look right here, look at the slop in this. This is ridiculous. This is why you don't just get a junkyard axle and throw it in a vehicle. So when you got these people claiming that they can do solid axle swaps for a couple $1,000s, that's the kind of stuff they're ignoring. They're not breaking down the entire axle assembly. They're not repairing everything that needs to be repaired and updating everything that needs to be updating. They're just slapping used parts together and hoping that they last. So when I removed the ball joints, this is what was left of them. This is just the cup. The ball and the pivot point sits in that rusty hole right there, and it just fell completely apart. Real bad shape. Here's the rotors and the hubs. The hubs are still attached to the rotors. Those get pressed off. You got the knuckles. The high steer arm's still on the driver's side knuckle. You got both axle shafts right there. And over here, what we got is our calipers, our brake backing plates, our spindles, and our auto locking hub assemblies. There are some parts out of the auto locking hub assemblies that I will be reusing, some clips and things like that, but hardly any of it at all. So before I talked about removing the high steer arm from the driver's side and I decided to get a reed knuckle, I'm just showing you guys these pictures real quick because this was a nightmare. Underneath those nuts right there, there's some conical, I don't know if you want to call them conical, I don't know if that's the right word. They're like wedge style washers that go inside of there. They're tapered washers, I guess, real deep taper, and they were stuck. And I was having issues getting them removed, and the MAP gas torch wasn't giving me enough heat, so this was my solution right here. I got the welder and I started running real hot beads across that side of it, and it was hot enough where I was able to remove two of the studs. The third stud I couldn't get out, but that's where the hammer came into play, because now I could just spin the high steer arm on the knuckle, and it eventually unthreaded and came right out. So, again, hours worth of fighting and playing. I wish I had a set of torches, but I don't. So in the intro to this video, I talked about my last update being a disassembly video that I put out, a year ago, over a year ago, whatever. Clearly, I'm still disassembling parts, and even after this section, I'll still do some more. um, right now, what I'm doing is I'm removing the front diff, basically the center section. It's a short little axle housing that the axle shafts bolt to. You can see, if you look up, you can see the CV boot and part of the axle shaft. I cut it off with my Everlast Power Plasma 50. I cut the lower control arms off and did a lot of cutting, and now what's left is the center section there that I'm going to unbolt and just literally drop out of the truck as one complete piece and toss it in the scrap pile. Something that I do not need for the setup. I just need it out of my way. So this is the last bolt. I'm going to take a hammer here, remove the jack, and start smacking it to make it come down. You'll see that it gets caught here towards the end. Everything's coming down slowly. There's a lot of dirt and grime and stuff holding it together, plus just the tension of the parts. I'm going to take my Milwaukee hacksaw, the M18 hacksaw, and cut the vent line that's still holding it up, and boom, it comes dropping down. Now our next step is to take the Dana 44 housing. We need to drain oil out of it to keep it from spilling all over the place, because there's no axle shafts in it. I don't try not to make a mess. So I'm taking taking the diff cover off. I'm installing my brand new heavy duty Chassis Unlimited diff cover. They're not a sponsor. I purchased this from their website. Really good product. My only issue with it is that it protrudes more than the factory cover, so you need to be very well aware of that. My high steer setup barely clears it. And that's basically the only reason it's clearing it is because of my pinion angle. So just be aware of that. You may have some clearance issues if you choose to go with that diff cover. Anyway, I got my inner C's blasted. I'm putting them back on. They're not being welded. They're not being tack welded. They're just being put on in the position that I believe is roughly the correct caster angle. Then I'm going to take this whole housing, put it underneath the truck. We're going to start doing mock-up. We're going to get the frame side brackets attached to the truck, the lower link mounts attached to the axle housing. Those I bought those from Artec. The frame side brackets on the truck I got from Rugged Rocks. I'm going to be building my own custom truss, building my own upper link mount on the axle side, and building my own track bar mounts, both frame and axle side, as well as modifying a high steer setup to work with what it is that I'm building here. So these videos here that I'm showing you right now, they're basically just a bunch of time-lapse videos of the work being done, and I'll do my best to try to explain things, but it's kind of random. There's a lot of stuff missing. It is what it is. What I'm working on here is the axle truss for the front axle. I'm using my Evolution Power Tools EvoMag 42 with a 2.5 inch hole saw to cut some brackets that I need for the truss that will saddle the axle tubes. I need 3 of these parts. The axle tube is actually 3 3/4 inch, but I don't have this saw, or the mag drill won't do 3 3/4 inch hole saw. Plus, I don't have that hole saw, so I figure I'll just use the angle grinder to open it up once I do so. And it worked fine. Everything set was real accurate. It worked out great. I'm using my Evolution Power Tools EvoSaw 380 to cut those brackets out. Cardboard template here will show you how accurate both of those tools made these parts. I mean, they're dead nuts on. Couldn't be happier. They helped this entire process tremendously to get my fitment and my everything lined up just right. Um, the truss is being made out of 3/8 plate, top plate. You got a top plate, and then you got your vertical supports that straddle the tubes, and then you got inserts that will be welded in between the tube, the actual tube, and the top plate. So kind of an I-beam type setup. Right here is the top plate. I'm using my Evolution Power Tools Rage 3 saw set at a very specific depth so that I can score the metal where I need to make my bends. I'm not cutting all the way through. I'm cutting far enough through where I can bend it, and then I can weld back that area once it's bent. After it's bent and everything is tacked into place, it's going to look just like this. I'm still missing parts here. Obviously, I don't have the inserts in. You can see above the axle tube there's a big gap. Yes, it's attaching to the inner C's. It will act as an inner C gusset. Should be super, super strong. I do not have my upper link mount on there yet. There's going to be some still truss work done in that area right above the diff. I'll show you guys that later. But in this picture, you also see the Artec lower control arm mounts that are tacked into place. Really high quality parts by Artec. Really happy with them. I'm actually using their lower control arm mounts on the rear axle as well, but that's a whole nother video. What we have here are the vertical inserts for the axle truss, the three pieces that you see on the right. Those will be welded in between the axle tube and the flat upper part of the truss. They're the vertical support, the I-beam, the center part of the I-beam type look. The two parts to the left, those are the beginning brackets for the track bar mount that will be built onto the axle housing itself. Still have a few more parts to make for that, but I'll be showing you the completed bracket here in just a few. So underneath the truck right now, what I'm doing is taking three pieces of 3/8 inch plate, and I'm building the extra extension off the top part of the truss that I told you earlier that I'd be building where the upper link mount attaches to. They're angled down. All three pieces have a slightly different angle. It's going to kind of have like a soccer ball effect to it where you got individual panels and all of them are at slightly different angles so that it creates kind of a domed effect. Everything's being tacked into place right now. Everything's rough. I'm going to be coming in later and cutting it as well as finish welding it, and before the upper link bracket is attached to it. So this photograph right here actually shows the three individual pieces put into place. Now I haven't done any cutting or finish welding on them, but I will be doing the finish welding here next and then grinding all of that smooth before I start putting on my upper link bracket. But before I start doing that, I'm going to do some mock-up and take the two sides of my upper link brackets, make sure they fit the contour to where they need to be so that I can figure out exactly how much material I can trim off the front of it. Now if you look at this photograph right here, you'll see the clearance that I'm working with on this truck, and you'll also see the upper link mount bracket in place. It's not complete, it's just the two side panels of it, but it's enough for me to check tolerances at full squat, make sure that I have the clearances that I need. You're also seeing the track bar and the tie rod in place. Ignore that. Again, these video clips and stuff are kind of out of place, and there was a lot of back and forth and in and out with this axle housing, so I'm just trying to show you guys the completed axle housing. What you'll also notice in this photograph is that extension I made off the front of the truss has been fully welded and ground smooth. Now that this is tacked into place, I'm able to remove the axle housing and do the trimming off of that so it's not all squared and everything, so it's angled down. The centerpiece will still be at full size, but the two end pieces will be angle cut back into the regular section of the truss. So it's a nice clean look. What we got here is a picture of my lower coilover shock mounts. Now I'm not showing you guys any of how this was built, but I'm pretty sure it's self-explanatory by the picture. Um, this is something that I struggled with quite a bit as far as the design. I didn't want to have them sit off the axle housing too much and create a bunch of leverage on there and potentially rip off. But you know, the way they're set up, they're pretty close to the axle housing, and everything fits up super tight. You know, there's enough of a gap between these and the lower control arm brackets where I can get all the bolts and everything out. But I mean, we're talking about a 16th of an inch type of clearance in almost every aspect of where everything fits up clearance wise, you know. Being able to get the wrenches and the nuts and everything into place. Everything's super tight, but it all works. Now, here's the track bar mount in the the completed track bar mount. There's not much to really explain here other than the fact that it's welded to the inner C. I've already set my caster angle on both inner C's. The truss, the upper part of the truss is all welded into the inner C as well. I still don't have the inserts in on the truss, but that's fine. We'll get to those shortly. I did make sure that when I made this bracket that I didn't have it open so that water or mud could get down inside of the actual bracket because it's hollow inside, so I didn't want any water to accumulate in there. So everything is sealed off in a way where no water or mud can get inside open cavities and just pool up and sit there. Now here's some couple of photos of basically the finished truss, finished axle housing as far as like all the fabrication is concerned. You'll see here the upper control arm mount is finished. I got the both sides in. I got a backing plate with a dimple dyed for strength. Everything's fully welded. I wrapped the weld onto the inside, not just on the outside, to give it added strength. What you didn't see is there's actually limiting strap brackets welded to the top plate of the axle truss. I didn't show you any footage of that because I don't have any. But they're just, you know, two little tabs there that were put into position for the limiting straps that I got from TMR Customs. We'll talk about that in a future video. So now on to the steering. What we have here is a photograph of both reed knuckles. One's the reed orange, the other one's not. I ordered them separately. If I would have ordered them together, they would have both been orange. Doesn't matter. They're not going to be orange, or, you know, the raw cast iron. When it's all said and done, they'll be red. Anyway, you got the spindles on them, and you got the high steer arms. The high steer arms I got from a company called Four Wheel Supply. They're based out of Richlands, Virginia. It's a small company, I believe. I don't know a lot about it, but I wouldn't be shocked if it was run out of the person's garage. Again, I don't know much about it. I know they're a little difficult to get a hold of at times, but the price on these high steer arms was super cheap, and they were the only ones that I'm aware of that did not have any machining done to the ends or any holes drilled in the ends, and that's exactly what I wanted. So what we're doing here is we're drilling holes in the ends for a 5/8 bolt, and you can see the Sharpie line on there. I'm going to cut that arm in two pieces. You see right here I'm using my Evolution Rage 3 saw to cut through it with a super dull blade that I completely ruined by cutting through this, but it is what it is. It did the job. And now I got two pieces. The reason why I'm doing that is because of this. Now we have the proper angle for the bolts to line up correctly with the double shear setup on the knuckle, but there was one other issue. From what I've been told, all the Dana 44 high steer arms on the market are not set up to do this double shear setup like this, and therefore they don't line up so that you can run a bolt all the way through. with these high steer arms and the modifications that I'm doing to them, it allows me to line them up properly. Okay, as far as being able to get that double shear set up, it allows me to line them up just right. Now, if you look at this photograph, you'll see that I've beveled the cuts and getting it ready for weld. Everything's kind of tightened up, snugged up, so that when I start welding it, nothing moves out of place. But you'll also notice that the angle of the arm has changed based off of everything being snugged into place. It's not a super flat fit. So it's not just the rotational aspect of the arm to get the bolt to line up and sit flat, but it's also an angle issue as well. Now, I'm not 100% sure if there's any arms on the market that are designed to do this setup, but I've been told at the time when I purchased these that there wasn't. So that's why we're making the modifications, and it is what it is. So now you see me here, I'm TIG welding them. I did have some problems TIG welding them. I really should have been using a large gas lens, a large cup with a gas lens, and I, because what I ended up having is some porosity issues and having to grind it all out and then re-weld it, and it turned into kind of a little bit of a nightmare where it shouldn't have been. But I got it done. Everything turned out great. There was no porosity, and when it's done, all ground down and mounted up, this is what it looks like. Looks pretty clean. Over here on the passenger side, we have the drag link attachment which mounts to the top side of the high steer arm, and I built this bracketry on top so that would be a double shear mount. So this drag link, where you see that heim there, it goes to the steering box. If you're not, if you don't know what that means. The tie rod is the one that's the double shear down below the high steer arm. And you'll see if you look at the diff cover that it sits above that bump out on the diff cover. Now this is before the truss was actually done or any of the other brackets were done. I got all this in place, made sure I didn't have any issues with clearance on the diff cover. I still didn't have the caster set in this, so there was a lot of figuring out later that it all ended up working out just right. Our next step is to tear the old differential out, the ring and pinion, get rid of the carrier. The carrier is actually limited slip from Ford, which won't work with our locker. Get rid of the gears. We're going to be putting a 513 gear set in there. And most importantly, we're going to be installing an Aussie locker. Aussie locker is made by a company called Torque Masters Industry. They're based out of Rochester, New York. The owners, Eric and Cora, are some really great people. They support off-roading, not just to sell their lockers, but, these guys are avid off-roaders, are constantly at competitions, and they got a club that they're part of called the Finger Lakes Off-Road Club. Just really good people, and I couldn't be happier to use our locker in my build. It's a great product, and they're a good company and just great people in general. I installed the locker myself. Real straightforward. The instructions are in detail and real easy install, to be honest with you. Now, I did have a friend of mine. His name is Matt. I won't say his last name, but big shout out to him. He did help me set up the ring and pinion. I've never done that before. Clearly didn't have the tools to do it. I'm sure he was frustrated with all my Chinese tools and hokey stuff that I got going on in my shop, but we got it done. I don't have any video footage of that happening, but right now I'm just buttoning up the Chassis Unlimited diff cover and getting ready to drag this thing outside and paint it. My wife's standing there giving me a hand for a quick bit because I got to pick this up and drag it outside. So, unfortunately, and we're going to talk about safety for a quick minute. Normally, I'm real safe when it comes to painting respirators, the whole works. I dug around my shop, was getting super pissed off, and I couldn't find my respirator to save my life. I don't know why, couldn't find it. So don't do what I'm doing here. Big risk. I paid the price. I felt like hell the next day and the day after. But I did what I did, and don't take these chances. So if you're looking at the housing right now, you'll see some primer. The diff cover's red. I'm shooting it with chassis saver paint made by Magnet Paints. Great product, super durable. I'm shooting that in black. I'm actually shooting the diff cover in black as well. The only reason there's red on there, you can see the mask on the masking tape on the diff cover. It's solely just for the logo, the Chassis Unlimited logo. But outside of that, everything was pretty straightforward and went real well. I'm real happy with the end results, which is right here. I didn't show you guys any of the assembly, and I apologize, but this video is dragging out quite a long time. But, you know, this is the final product. It's not installed yet, obviously. Matter of fact, still to this date, it's sitting on these jack stands waiting to be put under the truck, but I've got some stuff to take care of that I got into, and this is as far as other modifications being done on the truck, and, you know, it's not quite in. Anyway, real happy with the way it turned out. What do you guys think? As far as the parts and stuff that I put on it, what we have here is chromoly axle shafts. They're 4340 chromoly shafts that I got from Wild Horses 4x4. Their Wild Horses 4x4 specializes in Bronco parts, hence the name. And because I got a Dana 44 out of a Bronco, I went to them to ensure that I got the right axle shafts and whatnot. Now the stub axles, you can see, look a little bit different. Those are actually Chevy shafts. You have to do that because I'm running a Chevy outer. They're Chevy shafts for a Dana 44 or corporate 10 bolt. The splines are in the shaft, I believe it's a little bit longer, or maybe it's the snap ring holes are a little bit different, but something's different about them, I forget. So you have to get the Chevy ones, and I believe those are made by Yukon, but I still got them from Wild Horses. Now if you look at this photograph here, you can see the difference between the factory inner shaft right there on the rusty one and the chromoly inner shaft. There's a substantial difference in bulk, where the factory one tapers down in the center and also tapers down right at the splines. Those are serious weak points. They also use smaller U-joints. So that's one thing that you have to consider if you're trying to do this kind of swap with an early Bronco. You have to understand that you may have to change your axle shafts anyway, just to get shafts that have the same U-joints for both the inner and outer shafts. As far as other parts are concerned, nitro gears, 513 gears, lube locker diff cover gasket, national bearings, and Timken seals and bearings as well. Spicer U-joints, their 760 U-joints, and I replaced the C-clips on the U-joints with full snap rings. I believe that's what they're called. You have to use the snap ring pliers to install them and get them off. The C-clips tend to fall off and break, where the snap rings tend to hold them much, much better. I think that's basically it. You know, let me know what you guys think of this. Thank you guys for watching, and I will talk to you guys later.